Good afternoon, everybody. As was mentioned, I'm from the National Physical Laboratory. So NPL, for those of you who haven't heard of it, is the UK's National Measurement Institute. So we do everything from measure time, we have an atomic clock, temperature, but we also do a lot of work in applied science. So you may be thinking, why is the UK's National Measurement Institute here talking in a funding session? And as you can see, this is a graph indicating technology readiness levels, or TRLs. They were first thought up in the 70s by NASA, and we use them a lot at NPL to try and describe whereabouts we are working in a scientific area. So TRLs at the early stages are really R&D, proof of concept. TRLs for the later stages up to 9, it's when things are commercially available. And often you see business and corporate organisations working very much in the applied and higher level TRLs, academia and SMEs often in the earlier stages. And NPL has quite a unique role in that we work right across the mix. We do a lot in both proof of concept and working in developing the research science to underpin new technologies, but we also have a large number of corporate organisations who we work with. The key theme that runs between those two groups, the academia and SMEs, but corporate organisations, is that NPL is normally, in our role, providing assurance and confidence that one of them is saying the right thing to the other and that they're both telling the truth. And so that's what I'm here to talk to you today about, is trying to make sure you remember when you're going into these talks about funding that often it's the evidence and assurance which is overlooked. So, moving on, I had to think about how best to try and give you a brief overview of the type of work that places like NPL do in terms of helping technologies to move along the TRL levels. And I thought about 3 key barriers that we often see SMEs face. So SMEs are often coming to us wanting the assurance and verification and testing to try and overcome these 3 barriers. So for early stage technologies, in the early stage TRLs, it's about product development. So perhaps the product doesn't work as you thought it would, or the component parts work well separately but don't work at all when they're put together, or it's not economically viable yet. So that's the first case study that I'll give you. Secondly, you've got your prototype, it's in the middle stages of TRLs, but you need to scale up and you're lacking project financing, which is the main topic of today. And thirdly, the technology is ready for market, it's complete, however, the market still aren't taking it up, which is probably the most frustrating of all of these barriers. So, on the first example I gave you of early stage TRLs and product development, an example of where we've been working with some SMEs is in the fuel cells area, and it's already been mentioned today. So we have scientists at NPL who work specifically in fuel cells, and their history is of corrosion science. Now, the example of fuel cells given before was of a much larger scale, but another application of fuel cells is often to do with the automotive industry. Fuel cells at the moment face 3 key barriers. I mean, there is a myriad of barriers, but 3 big ones. One is the cost, one is durability, and the third one is fuel, which has already been mentioned. So this is about the durability section. So I'm not a fuel cell scientist, so please forgive me, but the fuel cell scientists have told me that one of the biggest problems around the durability of fuel cells is that they like to be left on giving a consistent amount of energy forever, for as long as their lifetime. They don't like being switched on and off, and they don't like being asked to produce more energy and less energy. And if you think about a car, it does exactly those 2 things. So you switch on and off, and you also increase the speed, decrease the speed, and you change the power output. Now, the more you do this, the more that the fuel cell corrodes. So NPL scientists went about trying to work with some SMEs to figure out a sensor that could be put in situ into fuel cells, which would diagnose what was happening in that fuel cell. So why is it corroding? And they were able to map the activity of a fuel cell. Now, this technology has been patented and is now being designed into new fuel cells so that it can be better mapped and managed, and the corrosion can be reduced as much as possible. So that's quite a good example of how the testing and verification can help an SME to overcome that first barrier of product development. So moving on to the middle stages of TRLs, we are approached a lot by manufacturers asking us to prove that their technology does what it says on the tin. Often SMEs face a lot of questions and scepticism, especially around green technologies, which is frustrating for everyone in that green technologies are often seen as being perhaps not durable. Often it's from misunderstanding, and sometimes these technologies lack any evidence that that the product does what it says. I think it's frustrating from an SME point of view. They see it as lack of trust or confidence that an investor might not believe that it is as amazing as they say it is. But if you think of it from an investor point of view, it's really a risk management tool. These technologies are often on the front curve of a new industry, so there might not be the standards out there for them to test their product against, or there might be a standard but it really doesn't suit the performance parameters. So, often they might have unique capabilities which go above and beyond a standard. So we kept on getting these requests coming in saying, could you please verify that our technology does what it says? We're at this break in our development and we can't get any further. And so we decided to join into a new EU scheme called the Environmental Technology Verification Programme, or ETV. So ETV was launched by the European Commission last year, at the beginning of last year, and it's aimed at innovative environmental technologies which are facing barriers to market. So this isn't for early stage technologies, this is for when a technology is needing investment to scale up, but it's being held up through, it could be a number of reasons, but for us, it's to do with proving that the technology does what it says. This is often the case with very new technologies where, as I said, there aren't the standards in place. And so ETV goes about verifying a technology by essentially producing a tailor-made verification. So a manufacturer would come to NPL and say, our technology works at this performance under these conditions. So we would then verify that and produce a statement which they then can go to investors with, which has an independent third party, which is very important, verification of how the technology works. This isn't a new scheme. It's up and running in a number of countries around the world, including the USA and Canada. And there's actually an international standard being developed to try and join up these different schemes at the moment. So within NPL, we work in a number of science areas, but we saw 5 technology areas as being of needing this kind of assurance work. So we're focusing on solar energy, energy efficient lighting, fuel cells, marine and wind, and smart infrastructure. And as an example of a technology which really needs something like ETV or this extra assurance work, we've got scientists who work in solar energy, and specifically new generations of solar energy. And they're always very frustrated, and we get a lot of manufacturers who are very frustrated because there have been standards around for solar energy for decades now. The standard works by producing a test where you shine a bright light on a panel and then they read the energy output. So for silicon PV, it works well under high light levels. However, if you were to look outside on a day like today in the UK, you will probably never, or maybe one day a year, get the kind of light levels that are being used in the tests. New generations of solar, such as organic PV and thin film, work much better and more efficiently under lower light levels. However, when they use the current standards, they're obviously being tested against established silicon, which looks much better. I mean, they're facing other problems with their product development at the moment, but it's one of the biggest issues for this new generation of solar, is that they're being compared very unfairly at the moment. So with ETV, a manufacturer can choose to do a verification at specific light levels. For example, you could do a verification looking at an average British day in terms of sunlight and how much energy would be produced, comparing that to what would be produced in silicon, for example. Add to that the innovative features of things like thin film, where they can now be printed onto glass to be used in buildings. It becomes a lot more likely that they might get some investment. Now, I couldn't talk in a funding session without doing something on a bit of funding. So at NPL, we obviously understand that the work we do in things like ETV is a commercial service, and for SMEs, everything is a cost and something they really don't need to pay for. So we do have a technology innovation fund. So for eligible SMEs, this can reduce the cost of accessing NPL expertise by about 50%. And there's some figures here about the impact that this fund has so far had. It's been open for a few years. And just do get in touch with me afterwards if you're interested in learning more about it. Now, this is my final slide, and there's a point, I promise, at the end of this. It's about the final stages of TRL. So when you've got your product finished, but you're still lacking market take-up, and this is probably the most frustrating stage, and it's something we see a lot in energy-efficient lighting. Energy-efficient lighting is a great example of where a technology has been out there for a long time, and it has really been waiting around for people to start to take it up, and there's been a lot of skepticism around changing from incandescent lights, and then we had compact fluorescent. And we have a lighting laboratory at NPL. It's one of the only ones in the world, and it can measure anything from the colour of light, the direction of light, the efficiency of light. And we work with a lot of manufacturers and SMEs to help them prove that their lights, won't make, for example, a supermarket's meat look grey, or will make a hotel room have the right ambience. And this example was one where we worked with a company who were producing lights for turkey farmers. And who knew that turkeys need UV light in order to recognise each other? Without UV light, they get really aggressive and cannibalistic. And so we worked with, turkey farmers, obviously they use a lot of light in their big barns. So it would make sense for them to go to LED. However, they were worried about the effect this would have on their turkeys. So we worked with a company to come up with the right spectrum of light that would calm the turkeys, and this has since gone on to be sold worldwide. So a point to take away for this is that when you're thinking about doing your testing and verification, don't just think about what you think is the best point about your product or the best feature. Think about what the investor or the end user wants, because the energy efficiency of the light bulb was not what they were worried about. They were worried about how their turkeys would react. So often it's not about what you think should be tested. People might not worry about the efficiency, but they want to know that, for example, the durability will still be good. So, and that's all from me. So thank you very much.
Well, you know more about turkeys than we probably do. Thank you very much. Any questions, Paul? Yes.
Could you get back to the slide on the technology innovation fund?
Innovation fund. Yeah.
I just wanted to hit it, that's all.
I knew that would be the one that caught everyone's interest.
The presentation was really fast, so you better catch it. So can you talk a bit about how it works? We apply to the Technology Innovation Fund, and they would then...
It's an internal fund. So if you came to NPL wanting to do testing or verification, essentially we would cost it up as a normal project, and then you can apply for the Technology Innovation Fund, and if you're successful, the day rate gets reduced. So, so depending on who's working on it, it can reduce it by about 50%.
Sorry, I have a follow-up question on that. Does this only apply to hardware solutions, or which need to use your testing lab? Sorry, does this only apply to hardware solutions which need to use your testing lab, or also software?
Yeah, it can apply. I mean, we do both testing, but we also do modelling and other areas. So if there's something, it's just about accessing NPL scientists.
Great.
Was there another question? Okay, thank you very much.
Thanks.